All right. So Dr. Hamilton joining us as the presenter facilitator today. My name is Vera Mays. I'm with the Learning Commons. I'm one of the math specialists. So if you come in for tutoring, you may have seen me along with a whole group of people to help you over here. But what she's going to give you is a very focused, brief view of what you need to know for the for test 4, not the final. Sorry. So I will be manning the chat. So if there's something that you have a question about, be sure you can put it in the chat, or if you want me to ask her, just put it in the chat and let me know. Then I can say, hey, can you go back and look over that part, or can you redo that part or something? I can be your quiet voice. So any questions before we get started?
I'm not gonna be here I'm not gonna be on there like for the rest. I got a tutor session at 6 o'clock.
Oh, okay. Okay, that's fine. Leave when you need to, you know, if you get what you need, if there's only one type of problem that you need help with, this is on you guys. This is what you need to get out of it. She's just going to be sharing with you the highlights of what she knows from teaching this class for quite a while, what's on the test and what you need to focus on. Okay, any other questions? The plan is, as soon as this recording stops rendering and we get it back from Zoom, we will be sending it out. That's our plan, as long as we don't have any technical difficulties and anything happens with it. So you should be, if you miss something and you want to watch it again or listen to it again, you should be able to do that. As long as, you know, I think we're going to actually send it to all the sections. So any questions? Okay, I'm going to
also get my camera up and running right here for us. Let me get it going one more time. Let's see it.
Oh, Dr. Hamilton, you have a lovely comment in the chat. It says you are worth the wait.
Oh, thank you so much. I appreciate you guys hanging out with us and coming to join us for the review. This is our last test. So here we are, ready to do what we can to clear up any questions, issues, or concerns that you have for the test 4, which would be our logic, not our logic section, but our probability and odds unit. In this particular section, you will not have a help sheet like you did with the previous sections. So it's all about knowing exactly what you need to know about your keywords. We're going to focus on that during our review. What the question is really asking, identifying those things that's going to help you try to remember that's located in the problem that you have to pay attention to. Now, I'm not sure if your instructor gave you an information sheet or a breakdown of this information sheet. I do have one available that kind of shows you of the breakdown of the unit and some things that you need to make sure that you pay attention to as far as the topics and the wording and the things that's going to help you to kind of remember what to do when they're asking you these questions. So we're going to be paying attention to whether it's combination, permutation, whether it's fundamental counting principles, whether when we're doing odds to probability and back again, where we're doing complementary probability and also conditional probability. So don't think too difficult about it. Don't overthink things. Try to think very light about it. We're going to try to make it as simple as possible. Okay, so trying to clear up any types of questions and issues. Again, make sure you put your questions in the chat, or you can raise your hand, or just simply turn your microphone on to alert us to let us know if you have a question. Ms. Vera is going to be there to assist with your questions, and also to guide me to help you to better help me help you understand what's happening. Okay. All right. So what I'm going to do is we're going to be working on, and everyone should have a copy of this in your class notes, is we're going to be looking at the sample of your test. I'm going to share my screen. This is coming right from your notes. I wanted to use this because that way everybody has the same document already available. This is your class notes. You should have 2 samples. You should be working on sample 1 or sample 2 in the back of your class notes, and or working on the online practice. Now remember, the online practice is more focused on homework problems. All right, so it's a little more challenging for your homework view, but also it gives you that syntax error practice. So make sure you pay attention to syntax error, how you're putting things in, how they want you to put it in. The test is going to be very straightforward, you guys. No tricks whatsoever. Okay, very light, much lighter than the homework itself. So if you can get through one of these these sample 1 or 2 here in your class notes, then you should be fine on the test. I promise you. Okay. We're going to go ahead and look at I want to go ahead and look at sample 2. Remember, your answer key should be already released for you in order to check behind yourself. Let's go ahead and start with sample 2. Go ahead and look.
Dr. Hamilton,
Mm-hmm.
there's some of the students that don't have these. Is there a way I can email them a copy real quick, or can they find it somewhere?
Sure. In your blank class notes in Canvas, do we have that available?
It happened last test, if you don't recall.
That yes, I do. I do remember. Hold just a moment. Let me fix this right now. All right, I'm going to send this. I think I can put it what it is. I think I put it in the chat last time, didn't I?
Yeah, I think so. And if for some reason you guys can't see it in the chat after a minute or 2 after it loads, let me know. And if you have your full name and the email, the login, I'll be able to email it to you.
Okay. Thank you. Okay. Pull this up. I'm going to do a couple things in here. Okay. The last time, did I give you all the blank class notes as well?
You did, yes. You gave us both, the ones you filled out and then blank.
Okay, so if you open up that document that I gave you last time, then the practice that we're doing right now is located in that document. It's at the very end of the lesson. You have it. So go to the blank class notes. Go all the way down to the bottom. Let's see. It's the last few pages in the document. Does everybody else, anybody not have it to where last time I sent the whole document to?
I don't have it.
You don't have it?
No.
I have a question.
Yes, ma'am.
I was really confused about the problems where it has the number and then the exclamation point after it. Do you know what I'm talking about?
Yes, the factorial.
Yeah, I'm not exactly sure how to do that. I don't think I'm doing it right in class, so I'm not really sure.
Yeah, we're going to talk about those as well.
Okay, thank you.
Absolutely.
Okay.
Okay.
Well, Lily put one in.
Yeah,
I found mine.
in files.
Yeah, I have it right here. It took a minute to load because it's kind of a large document. Okay. Trying to see if it's going to let me drag it.
I think I just put it into the.
Yeah,
The
So I
chat
think we're
did.
good. Yeah, I think I did it.
I'm trying to see, make sure I can open it so other people, I know other people can too then. Let's see. Yeah, I can get it to open. So
Good.
if you save it to your desktop, then it, when you go to open it under documents, it should be right there. If you guys can't, let me know and I will send it to an email.
Thank you, Lily.
Lily on the spot there. Good job.
Yeah. Okay. All right. Is everybody opening it? All right.
Yes, ma'am.
Okay.
But
Great.
if we have the package, we don't really need that, right? If we have the package, right?
If you have the blank class notes, then you don't need it. You
We're
already
doing it
have
for a
it.
test review paper. Okay, all right. Okay, thank you.
Okay. All right, good. So now we all have the same document. And to make sure that we are all good. Good. Now we are ready. So let's go ahead and start working through our problems. So now we have it open. Go ahead and start working. Okay. We're on sample 2. Okay. Sample 2 is what we're looking at. Go ahead and work problem number 1. And I'm going to go ahead and share my screen in just a second. Waiting for the thing to come up. All right. We're going to start with question number 1. Boy, this technology, I tell you, it just wants to act up for the 4th test. It doesn't want us to leave. That's what it is.
It doesn't want the semester to be over, huh?
It doesn't. Nope.
We cannot let that happen.
I know.
And if I remember right, we have a few people graduating in this group too. So I recognize some of the names. So
That's
woohoo.
right. Congratulations. All right. Okay, now I think it's gonna let me share now. Okay. Now it's happy again. Okay. All right, so we're doing number 1. Let's go ahead and do number 2. Number 3, but out of number 3, we're going to do A. And we're gonna do C. We're gonna do number 4. Number 6. Okay, working on those right now. Okay, number 1, number 2, number 3, parts A and C, 4 and 6.
Yeah, I'm already stuck on number 2.
That's fine. And if you're stuck, that's okay. Just move on to your next part. Okay. Good test taking. If you feel stuck, remember you got your notes there so you could take a peek. Okay. But if you feel like you still are unsure, go ahead and move to the next one, and we're going to get it when we come back. Sure will.
Number 1's just making me hungry.
I know, right? It is dinner time. All right. Did the page go away?
Oh, I see the answers now.
Uh-oh. You're not supposed to be seeing the answers.
That's what I want to have. That helps me study.
You're not supposed to see the answer. But now you got a glimpse. Okay.
The answers I see are for sample 1 though.
Uh-huh. Gives you kind of like an idea. It gives you an idea, but it's a different mix. That's why I kind of wanted to make sure that you have sample 1 to do on your own. And remember, you can do this as many times as you feel comfortable. So I suggest you print it out several times and do it. Make sure you don't look at the answers each time, because you know you got them there to support you. All right, so do it until you feel comfortable. And as soon as you can feel that comfort, then you know you got the test. Okay, the test is all yours right then. Come back here. It still wants me to do my own thing. My technology is so weird. Wants me to share, it doesn't want me to share. Wants me to share what it wants. All right, we got a couple of more minutes, very, very few minutes. And then we want to start talking about it. Try to go with your first thought, everybody. That's always usually puts you closer to the right path, right? But as soon as you start overthinking it, you start making up stuff. Don't do it, all right? Go with your first thought. Remember, you've seen this stuff before. We're just bringing it back to life. Should be almost there.
I'm just trying to remind a few people also that if you haven't put your full name in the chat, please do so, or your TCC email, either one.
Very important. Also, remember, if you have some calculator issues, please let us know that so that we can try to help you resolve those before you get to the test. You should be using the calculator that you are going to be using on the test, along with your practice, so that you can know exactly how to manipulate your calculator. Okay, that is very important. Right. Are we about ready? Do we need more time?
We can start.
Beautiful. All right. Giving us that good warm up to initiate. And then once we start getting our juices flowing, then we can start moving a little faster now, because then we got our thoughts together. We know what's going on. We're remembering some stuff. So making sure that you're paying attention to what's happening. So here we are moving to our lesson. All right. We're looking at number 1. Number 1 says, a restaurant offers a choice of 11 salads, 21 main courses, and 12 desserts. How many possible 3-course meals are there? What kind of question is this? What kind of problem is this? How should we approach it?
Combination?
Not necessarily. Because if you set it up as a combination, it will still end up being another form. What's another form that it could be?
Is it permeation?
No, not necessarily permutation, because permutation means that it has what to it?
Order.
Order. Are they asking us to order anything here?
No.
No, no order. Okay. So that leaves what?
Fundamental counting principle.
Fundamental counting principle. Okay, beautiful. So we're going to need a line representing each one of these things. Now, you don't have to draw the line if you don't have to. Okay, if you don't want to, that's fine. Okay, but you can make sure you have an opening. Oh, undo. Make sure you have a line representing each thing. Reload. Hecky darn. I gotta, oh, hold on. I gotta rotate a couple of times. I'm missing pitch rotate. So a line representing each one of these categories. And then you're going to choose. If you are to write using a combination, it's still end up going to be a fundamental counting principle because you're only choosing one of these items. Okay, so fundamental counting principles is the way to go. All right. Yes, reload. Oh. There it is. Okay, so we have my color back. All right, so we have 11 times 21 times 12. One line representing each one of our categories. So we have salads, we have our main course, and then we have our desserts. When we multiply these things together, it's going to tell us how many possible 3 meals there are. What number did you get?
2,772 meals.
2,772?
Yes.
Did everybody get that?
Yes.
Yes.
Yes, ma'am.
Yes.
Wonderful. Okay. Number 2, the probability of winning a race is 5/12. What are the odds against winning the race? How are we going to do the problem?
Your circles.
Your circles. And how do we know we're going to do circles?
The word odds.
Okay, odds. And then they're asking us to go from one thing to the other. So probability to odds, for sure, we're going to use our circles and that helps. So just drawing our circles, right? We call it, I don't know, our face. It's a weird face, right? Remember that we always have our total on the bottom, right? And remember, whatever you're talking about is always going to be your first circle. So we're talking about winning a race. So we have win, and then we have no win. Right? Win and no win. There we go. All right, so now, here we are. Tell me what goes in the total circle.
12.
12. They gave us probability. So remember, probability always goes from top to bottom, right? And our total is always in our denominator. So here's 12. And then they gave us the probability of them winning the race. So that's always going to be on the left side of your circle. So we have our 5 goes in the win circle. Is everybody okay?
Yes.
Yes. What number goes in the no win circle?
7.
7.
7, because we know that the 2 circles on the top add up to give us the total. So 12 minus 5 leaves us 7. Is everybody all right with that?
Yes.
Yes, good. Okay, now we can answer the question. What are the odds against winning the race? This tells us the direction we need to move for our odds. What's the odds against us winning the race?
7 to 5.
7.
7 to 5. All right. So remember, we start from right to go to left. So odds against is right to left. Tell me, what is the probability of us winning the race?
5 to 7.
No. The probability of us winning the race.
5/12.
12.
That's what they gave us, right?
Yep.
What's the probability of us not winning the race?
7 to 12.
But say it the right way.
7/12.
There you go. 7/12. Wonderful. Okay, so we want to make sure we don't mix up the odds with the probability. So remember, probability is always something over something, right? Always over the total. And odds is always this to this, okay? Using our colon. So tell me the odds in favor of us winning the race.
Five over 12.
5 to 12.
5 to 7.
5 to 7.
Oh,
Do you see it?
I see it.
So you got to pay attention to what they're asking. The wording makes a difference. Okay, so here you have odds. Okay, right now. Oh, hold on, I need to get my cord.
No, it's about to die.
Okay, so if I ask you about odds, always remember you're going across the top. On the test, when you see this question, they're going to have two parts. Okay, two parts. And it's going to be at the top, they may ask you, what is the probability of this, right? So you open up, you gonna fill in the slot. Then they ask you, what are the odds? And they're going to have the colon there for you. All you have to do is fill in the right numbers. Okay, so it may be two separate questions, or it might be a combo question. All right, so watch it. So you have odds in favor. Okay, odds in favor means 5 to 7. Odds against, we already know 7 to 5. You just flip them. They told us what the probability of winning the race is, 5/12. So the probability of not winning, right, is going to be 7/12. Does everybody see the different answers?
Yes, thank you.
Okay, good. All right. Read the question carefully on the test. All right. Okay, suppose we have number 3, and the 3 carries A through C, but we're going to do A and C. Suppose the odds in favor of me wearing blue socks are given as 75 to 1. What is the probability that the next time we meet, I will be wearing blue socks? So do we agree we got to do our circles again?
Yep.
Yes.
Okay, so here's our circles. Labeling, we got our total. And then we have blue socks. No blue socks. Tell me what goes here in our blue circle.
75.
Okay. And then what goes here in our no blue?
1.
1. And then our total?
76.
Is everybody okay with that? Now
Yes.
tell me, what is the probability that the next time we meet that I'll be wearing blue socks?
75/76.
Okay. If my dog never wears blue socks, what is the probability of him wearing blue socks when you meet or when you see him next time?
0.
0. Is everybody all right with that?
So are we able to just
Yep.
put 0 in the answer key and it accepts it?
Yeah. Yep.
Okay.
Now, I'm glad you asked that, Wendell, because if they say, if the answer is this, put this. Okay, so read the directions because sometimes they'll give you that sub direction. So if the answer is 0, put this, follow their direction, but you should be able to put 0 because it's 0.
So the answer to this is 0?
Yeah.
How?
Do you see why?
No.
Well, it says,
It said if my dog never
Oh.
wears blue socks.
do you get it?
Yep.
Yes.
Do we know anything about his dog?
Nope.
No. All right, so the setup of the problem didn't have anything to do with this dog. It had to do with him. All right, so if his dog never wears blue socks, we don't care. We don't know anything about it. It's 0. Do you see how they're going to change the words on you, but you got to read it and pay attention. It has nothing to do with our problem. All right, so paying attention to the problem. Okay, number 4. Did we do number 4?
No, ma'am.
Okay, I think we skipped that one. Yeah. Do number 6 here. It says a tray contains 35 pieces of fudge, 11 peanut butter, 12 vanilla, and 12 Rocky Road. You randomly select a piece of fudge, eat it, and then randomly select another piece of fudge. Find the probability of selecting from the tray a piece of vanilla fudge and then a piece of Rocky Road fudge. Tell me, what are we doing here? What kind of problem is this?
I know it's a probability, but it's like, I forgot how the teacher ended up saying it. He said like, you put, first you'll start with the first one, which is the vanilla fudge, which is, that's 12 out of 35 pieces. So it'll be 12 over 35.
Okay.
And I guess since it says, hold up, since he selected a fudge, he eats it and then randomly selects another piece of fudge. So if he did that, it'd be, so the second piece of fudge is the Rocky Road, and I guess that's 12 over 34.
Okay. But what are we doing? Are we adding them together? We multiplying them together? We
I
subtracting
think
them?
you're multiplying it.
Does everybody agree with that?
Yeah.
Yep.
Okay, so we have 12 over 34. So in the problem, the key words here, eats it. Okay, so this implies for us that we can't put it back in the tray. We can't put it back on the tray. Okay, so this is without replacement. So that
That's
means
the
that
word. That's the word I was looking for, without replacement.
Okay, so without replacement. Then he says the other keyword we should be looking for, paying attention to, is and. Right? So and means, what do we do to our probabilities? We multiply. Right? So probability of vanilla fudge the first time and Rocky Road the second time, we're going to multiply those two probabilities together, taking into consideration that we're going to be missing one of our totals at the end, right? Or for our second probability. Is everybody all right with it?
Well, what I'm not understanding is I'm not understanding why. No, I got it. I answered my own question. Sorry.
Oh, that's good. I like it when that happens. That's wonderful. But does everybody see it now? All right, so now when
What if it's, I got one question, because I just did one of these for the practical exam for the homework.
Mhm.
What if that random piece of fudge is the peanut butter and it would be 10 over 35? Or 12 or 11?
The peanut butter, if the random one was a peanut butter,
Yeah. So how do you choose 12 over 35 when only vanilla and Rocky Road is 12? So why is 11 excluded?
well, they didn't want us to choose a peanut butter. And it's not excluded from the total. It's just excluded from the fact that the first piece, they wanted it to be a vanilla fudge. So the total number of vanilla we have in the whole 35 pieces is 12 pieces.
No, I'm tracking that. I'm just saying if you send me this question without knowing how to explain this, I would take 35 and then I would be confused. You randomly select a piece of fudge, eat it. It doesn't say peanut butter vanilla. It only says that, and then eat a piece of Rocky Road fudge. Or maybe I'm wrong.
Well, if you look on the second statement, it tells you how you're doing it, right? It's not until the actual question at the end that it tells you what you're selecting. Do you see that? It has to tell you at what rate, I guess, so to speak, at what rate or how they want you to choose the pieces. So now at the end, the question is, what do they want you to choose? Does that make a little more sense? So that if they didn't have this second statement in here, you randomly select a piece of fudge, eat it, and then randomly select another piece. If they didn't have that piece in, it wouldn't be really clear on finding the probability of selecting a piece of vanilla fudge and then a piece of Rocky Road, because you don't know if the person picked it up. Now, I don't know, some of y'all might know what I'm talking about. You pick it up, you're like, oh no, it's gooey inside, and you put it back, right? Then you pick it up.
We need to move on, but I don't want to hang up on this question too much. But if I read this question right now, and when I take the test tomorrow, I will probably just write down 11 over 35 times 12 of 34. Like, I know how to solve it. I just don't understand where you got the first 12 over 35 instead of maybe, because it doesn't say randomly select a piece of vanilla fudge, but then it says okay, I just answered my own question. Vanilla fudge and, yep, I didn't see that. You just had to highlight that real quick and I would have shut up.
Yeah.
Yep, there you go. Yep, that's all I needed to know. Yep.
Okay.
I didn't see it.
All right. Any other questions? So reading, very important. Okay, so you can get all the details. And now,
Dr. Hamilton.
Yeah.
I had to go. I got a tutoring session at 6 o'clock.
Sure, and then remember, you can always look at the recording afterwards.
All right, thank you.
All right, thanks, Wendell.
No, that was Blake. Hello?
Huh? Go ahead.
I said Blake.
It's Blake that's leaving.
Oh, Blake. Oh, okay. Thanks, Blake.
All right.
All right. So when we multiply, what do we get? What was our final answer in a simplified fraction form?
144 over 1190.
So 144 all over 1190. Can we simplify that?
Yes.
To what?
72 over 595.
72 all over 5 what?
95.
Is everybody okay? Make sure you use your F to D button. Okay? Your F to D button to simplify your fraction. They will ask you in a direction to enter a simplified fraction or a decimal number. Make sure if they ask you to round, you round it to the proper place. All right? Looking at number 7.
What are we rounding?
We didn't round anything. We just simply wrote our fraction in a simplified fraction form. We simplified it.
So like if there is a decimal place, what number do we round it to? Like what point?
Whichever one they ask you to.
Oh, okay, thank you.
Yeah, most of the time they'll ask you to put in a reduced fraction.
Oh, okay, thank you.
Can you use your F to D button to do that?
Yes, that's correct. Unless you have a graphing calculator, then you go to your math button.
Oh,
Your
wow,
math.
I never knew that. Okay, thanks.
Absolutely. All right. So number 7 and
I have
number.
a question.
Go ahead.
Like, how do I do the 144 over 1190 on the calculator to get the 72,595?
What kind of calculator do you have?
The TI-30X2S.
Right. You should have an F to D button. I believe it's located over your probability button. It's in the at the top, I believe, where your probability button is. Is that correct? Either you have.
I just click on math and click fraction and get the answer in a fraction, and it comes out completely simplified.
That's if you have a TI-83 or an 84.
Oh, okay. All right.
So
Yeah.
what calculator did he say he had? I'll look up a picture.
Yeah.
The TI-30X2S.
You have a S to D button, or you have
Yeah, the F to D button.
or an F to D, or you have a toggle button that has like 2 arrowheads pointing away from each other. That's over your enter button.
It's over the PRB button. It's this from second row from the left is where the F to D is. It's
what
in
I'm saying
blue.
is, it's like, how do you, in order to get the 72 over 595 from the 144 over 1190, like, how do I, like, for a step, how do I go?
In your calculator, put in 144 divided by 1190. Then push enter.
But when I did it, it gave me a decimal.
That's what you need.
It gives me a decimal.
That's what you need. And then you're going to push your second function button, and then push your F to D button, which is your probability button.
Okay.
All right. And then push enter.
Oh, so that's how you do it. Hold on, let me try that again.
Okay.
Remember, if you have any trouble working your calculators, come to the Learning Commons. We'll sit down with you and make sure you know where those things are.
Yeah, because let me see, 144 divided by 1190.
So go ahead. While we're working on practicing that, go ahead and work on numbers 7, number 8, numbers 9.
Got it.
Number 12. Sure. Oh, I don't know nothing about the test. I didn't see it.
So there was a question in chat. Do the teachers count the practice tests, or are they required in this class?
No, we're not required to do that. That is up to your instructor if they want to incorporate that into your as a bonus or extra points for you.
So what does Dr. Hamilton do? Because we have some of your students in here.
They know what I'm going to do.
They're asking.
No.
Just to make sure.
I am going to do something else though, but no.
Ooh. You heard it here.
You did hear it here.
Is it too late to enroll in your class, Dr. Hamilton?
Yeah, no, yes.
I know, right?
A little too late. All right, go ahead and get number 10. So we're working on 7, 8, 9, 10, and 12. All right. These are going to be some good ones. You should be getting a deck of cards on the test. So if you don't know what the deck of cards are and you still are struggling with that, you won't have to worry about that on the test. You will get a picture with the problem. Okay. The same with the dice as well. Usually, if they're going to ask you about the dice, just like on your homework, you will get a picture of the dice, especially if it's a large amount of dice they want you to look at. We're going to start talking about it a little bit. These should go pretty smoothly now. Start feeling it a little bit.
You said 7, 9, and 12?
7, 8, 9, 10, and 12.
Oh. All right, should be about ready. You ready to start looking at it? We're gonna
go ahead and start looking at number 7. So it says, number 7, you randomly select one card from a 52-card deck. Find the probability of selecting an 8 or a black card. Tell me the keywords in this problem. What is it?
Or.
Or. What do we know about or?
You add it.
You add the probabilities and then do what?
Subtract one.
Okay,
So
subtract the overlap.
Yeah.
Okay, good. All right. So here we have the probability of an 8 or a black card. Okay. So we know we have 52 cards in a deck right there. There's our 52 cards. How many 8s do we have?
4.
Okay, 4 8s. Plus, how many black cards do we have?
26.
26.
That's right, 26. Are any of these 26 cards, these black 26 cards, 8?
Yeah.
How many?
2.
2 of them. We got to subtract out those 2. Is everybody all right with that?
Yes.
Okay. So now when we do our magic, that gives us 30 minus 2, that's 28, all over 52. Can that be simplified?
Yeah.
Yes.
Okay, now that we know how to do our magic in the calculator, what do we get?
7 over 13.
Okay, did we get 7 over 13? Is everybody okay with that?
I got it.
Yes.
Okay. All right, so 7 over 13.
So for the cards, even if it said we selected like a 12, it would be the same. There would be 4 12s usually.
Oh, well, let's say if they said select a 10, then there'll be 4 10s. Yes.
Okay. Yes. I didn't. Yeah. 12 was.
I know what you mean. I know what you meant. But
so
yes.
I know about cards. But yes. Okay. I just wanted, and then so there would be 20. There would be 26 red cards as well, right?
Yes.
So, okay. Okay. Thank you. I just want to clarify.
Yes. Okay. Any other questions about that one?
The card, you're gonna give us the deck on the test, right?
Yes, they'll give you a picture of the card.
Okay.
Yes.
All right. So number 8, it says 300 people purchased a raffle ticket. 3 winning tickets are randomly selected. If the first prize is $500, the second prize is $250, and the third prize is $100. And how many different ways can the prizes be awarded? Okay, what kind of problem is this?
Permutation.
How do we know it's a permutation?
Order.
Order. Okay. First thing is prizes. First place, second place, third place. But if they say raffle, contest, any of those words that mean that there's something going on that can be awarded or won, then more than likely it's going to be a permutation, right? And then once you solidify it with them giving it order of first place, second place, third place, you know it's going to be permutation. Now, you can also do what? How can we also set up the problem?
You can take the 300 people and then times it by 299 and then times it by 298.
Right. So fundamental counting principles. We can go our 3 lines, right? And we do first place, second place, and third place, right? And then we can go ahead and multiply by our 300, right? Times 299 times 298. Or set it up as a permutation. 300 tickets, perm, 3 prizes. Is everybody all right?
I just have one question. You said that we know this is a permutation because it was a raffle or contest and because it required order?
Mm-hmm.
Okay.
Yeah. Permutation is order.
Okay, thank you.
Mm-hmm.
So that's because it did first prize, second prize, third prize?
Yes. Or if they said, we're going to choose some people and we want a vice president, president, secretary, that's order. They're putting people in categories. Okay, then that's some type of order. Does that make sense? So once they start ordering things, or even if they give you the word order, then you know some order is going to be there. What's our answer? Should be some really big number.
26,730,600.
And that's why I never win.
That I hardly win either, but you got to play a lot too. So is that the number right there? Did I write it right?
Yes.
Okay.
Yes, ma'am.
Did everybody get it? Is everybody okay with finding your permutation button?
Can we go over that really quickly?
Mm-hmm.
I'm sorry.
You mean as far as finding it in your calculator?
Yes, ma'am.
Okay, what kind of calculator do you have?
I have the TI 84 plus.
So that's going to be in your math button.
Yes, ma'am.
Go all the way to the top menu, you will see PRB.
Uh-huh.
Okay, scroll over to that.
Uh-huh.
And you should see it in your second, number 2, 3, and 4.
Mm-hmm.
Is your PRB. So you have to tell in your calculator, put 300, then go to your button and find, select your P. You can either put the number that is next to, associated to,
Mm-hmm.
or you can move your cursor to it and push enter.
Yep, I just got it.
Okay.
Awesome. Thank you so much. And then I also have one other question. So for this one, I just find using the counting principle, the fundamental counting principle, kind of easier. So if I wanted to choose to use the fundamental counting principle over the permutations thing, how do I know that reading number 8, I could still use the fundamental counting principle? Is it because anytime you can use a permutation, you can use the fundamental counting principle?
Yeah, if you have permutation, you can usually use the fundamental counting principles with it.
Okay, thank you.
You can use either or.
Okay, thank you.
Mm-hmm. Just make your line for each one of the things you have a category for. Yeah. All right, number 9. It says a 6-sided die is rolled. The set of equally likely outcomes is here listed. Find the probability of rolling an even number. What's the probability of rolling an even number? How many even numbers do we have?
You have
3
3
out of
even
6.
numbers.
So
Okay.
half.
3 out of 6, which equals 1/2.
1/2.
Right.
Yep. Okay. Everybody all right?
Yes.
Okay. Number 10. A 3-person committee is to be selected from a group of 11 people. How many different committees are possible? What kind of problem is this? Where's our keywords here?
Committee.
Committee. What does committee tell us?
There's no order,
No order.
so it's a combination.
Perfect. So no order means it's a combination. Set it up for us. What would it look like?
The 11 combined
11.
3.
It'll be 11C3.
C3. Yeah.
Perfect. Is everybody okay? So now we put it in our calculator and we get what 11C3 is. And what is it?
165.
Okay. Is that what we're getting?
Yes.
Okay.
Yes.
Could you again go over how you do this in your calculator? I know it's NPR and you select the combination, but do you put the number in first and then select NPR, or how does that work?
You have to put 11 in first. You always have to put your N value in first. And then go and get whatever you need. So we need our combination button. And then put in 3.
Got it. Thank you.
Mm-hmm. Okay. Number 12. 12 says, find the number of distinguishable permutations of the letters in the word Mississippi. Okay, so how are we going to do this one? Do we remember?
Count your matching letters.
Okay, so we got to count the matching letters. So how many, just count the ones that are repeating.
Yeah.
Okay, what else do we need to count?
All the letters.
Okay, so first we got to count all the letters. How many letters do we have?
11.
Okay, 11. All right. Then count all the repeating ones. So we don't have repeating M's. But what about I? How many I's?
4.
Okay, how about S?
4.
4.
4. And P?
2.
2.
Okay, 2. And that's it, right? Okay. Now our third step, bringing it together in our formula. So our formula tells us to take that total, do our factorial. Here's our factorial question coming in, all over the factorial of our repeating numbers. So we have 4 factorial times 4 factorial times 2 factorial. We're going to multiply by the factorial of our repeating numbers. And that is going to give us our result. Now, if you want to go ahead and simplify your bottom, that's fine. You can do that as well. So remember what factorial is. Is everybody clear with what factorial means?
I'm a little foggy on it.
Okay, so 2 factorial should equal 2 times 1. So factorial just simply means that you're decreasing your number by 1 all the way down to the number 1. So 2 factorial would be 2 times 1. So that's just the number 2. Is everybody okay?
Yes, ma'am.
So 4 factorial would be what?
4. 4 times
4 times 3 times 2 times 1.
Beautiful. Okay, so 4 times 3 times 2 times 1. So instead of us actually putting those numbers into our calculator now individually, we have a button in our calculator, the same place where our permutation and combination button is, that we can just go ahead and put that in individually, and then that will work. So you should be able to do this all in our calculator at the same time. If you are doing it all together at the same time, you need to put parentheses around our denominator to tell your calculator that you want all of this to stay at the bottom of your fraction, right? So you can do that. Some people also will go ahead and simplify each one of these and find out what they are, meaning that they'll find out what 4 factorial is. We said that 4 factorial is 4 times 3 times 2 times 1. What's 4 times 3 is 12, right? And 12 times 2 is what?
24.
Right? So each one of these is 24. So another option is 11 factorial all over 24 times 24 times 2. So you can go ahead and put this right here in your calculator and get your number. And then you can say 11 factorial divided by whatever this number is here. And that might be easier for you to do in the calculator. It is really up to you and your comfort level as to how you want to break this thing down. There's no right or wrong way. Is everybody all right? You just need to be able to do it one way or the other. All right? So there is no right or wrong way.
So would you just leave the 11 on top? So it would be 11 factorial over, no?
No, you actually have to go ahead and put it in your calculator. 11 factorial divided by whatever the denominator is.
Okay.
Mm-hmm. Okay. We should be coming up with a possible now.
Just a heads up that it's 6:20.
Okay, thank you. All right. What are we getting?
34,650.
Okay. Is everybody getting that number?
No, ma'am.
Okay, are you putting 11 factorial divided by your whatever you get? Did everybody get this number right here for your denominator? If you broke it down like this?
Yes.
Yeah, so you should get 11 factorial divided by 1152. When you push enter, you should get.
Wait. Hold up. I think, hold on, let me see. Divided by. Oh, man. Hold
Is
on.
everybody finding it okay?
Yes.
Yeah.
Okay, I see what I did. I didn't multiply all those out first before I end up dividing the layer factorial over the 1152. Okay, I got it.
Yeah, cool. All right. Again, many ways to manipulate it. All right. How are we feeling about it so far? The test. How are we feeling? Are we feeling better about it?
Yes.
So much better.
Much
A
better.
little better, but I'm still kind of stuck on the words about I don't know those keywords. I'm really just don't know where even to find them in the notes because we didn't go over specific keywords and what they meant.
Okay.
So I'm confused.
Okay. All right. So those things are there. They are in the notes because they're part of the actual learning of the part. But I do have something that I think might help. Okay. So I do have something that might help break it down a little more. All right. Let's try.
Thanks.
Sure. Let's try and see about doing problem number 16. All parts, let's do, just to make sure that everybody is clear on what's happening, do A, B, and C. Just want to make sure we're clear on those. So 16, A, B, and C. Numbers 18. And let's see if we can squeeze in number 20. 20.
Please do number 20. Oh my gosh.
Please.
I kept getting that wrong on the homework.
Okay, I got you. All right. Let's see what we can squeeze in there. Okay, let's go ahead and work that. All right. Yeah. Think about what it's asking. We already know it. They're just breaking it up into pieces. All right. And the pieces actually help. Right. Should have read the question now.
I know for me, like for number 16, I don't even know where to start. That's the part that confuses me, I feel like half the time. Like I think I'm doing the overthinking thing because when in how many ways can they arrive? I'm like, okay, if they all arrive different times and they all arrive randomly and there's 1, 2, 3, 4, can they just arrive 4 different ways?
Well, no. Well, how many people do you have is the question. So you have 1, 2, 3, 4 people.
Mm-hmm.
All right. So how many ways can they arrive? So if you have 4 people, that's where your lines come in at. So how many ways can the first person arrive? So in the first place, right? How many choices do you have for the first person to show up?
4.
4 people, right? You got 4 people to choose from that could show up,
Okay.
right? One of these 4 people are going to show up.
Yes.
Okay, so after that one person that showed up, now how many more people do you have left to show up in the second spot?
3, 2, 1.
Three to choose from. And then how many left?
2.
And then
1.
do you see that?
Yes, ma'am. Perfect. Thank you.
Or you can say 4 factorial. Do you see 4 factorial?
Yes.
Okay, so we already know what 4 factorial is now. So what's 4 factorial?
24.
24.
24 ways, right?
See,
That they
like
can
when you
arrive.
explain it, I see it perfectly, but then I'm looking at it and being like, I don't even know where to start. Like I got, thank you.
Okay, this could also be it's a permutation. So you have 4 people choose 4, you know, but you can easily use your fundamental counting principles here. But now look, the second one says, in how many ways can Beth arrive first and John last? So now they're giving us some restrictions, so to speak. So now we got these 4 people, right? And they're telling us that Beth has to arrive first. This is Beth, right? And then John has to arrive last. How many people is Beth?
1.
1 person. And John is how many people?
1.
1. So you only got 1 option for the first place and 1 option for the last place. So how many people does that lead to arrive?
2.
2.
Right. So for our second place, you have 2 choices. And then you got 1 more person that needs to arrive.
1.
Oh, wow. Thank you so much.
Does it make sense?
Yes.
Candy.
So how many choices? So after we multiply together, do you see it's only 2 ways?
Yep.
This can happen. So when you put the restrictions in, they're going to give you what we call the restrictions or the specifics. Go ahead and fill those in. We only have 1 option for Beth to arrive first and 1 option for John to arrive last. That only leaves 2 people to order. So you got 2 options for the second place and 1 option left for that third place. So that leaves 2 ways that only this arrangement can happen. So now look at the third one. It says, now find the probability. You see that? That Beth will arrive first and John will arrive last. So now what's the probability of this happening? So probability tells me that I should have what? What shape is a probability?
A fraction.
It's a fraction. All right. So tell me my denominator.
4.
What's my my denominator?
Will it be 4?
No, not 4. It's always the total number of ways something can happen.
Okay, 2.
24.
2.
It's
How
24.
many?
Oh yeah, 24.
Right? How many ways can they arrive? That's your total number, right? Of ways this thing they can arrive to the party at all, period. So 24 is my denominator. But now, What's the probability of this happening? This particular way of them arriving?
2.
2. That's my numerator now. You see that? So the probability of this happening is 2 over 24, which reduces to what?
112.
Does everybody see it now?
Yep.
Yeah.
So probability is always going to be on the bottom. Even when we look at our circles and we were looking at anything, probability is always going to be the total number of ways that something can happen is on the bottom. But then that numerator is always going to be that specific thing they want you to look at, that specific arrangement. Okay, how many ways that can happen? So this question might be on the test broken up just like that. Number 18. Okay, it says a small town has 4 police cars. When a call comes in, the dispatcher may dispatch no car, 1 car, 2 cars, 3 cars, or all 4 cars. If a call is received, how many ways can the dispatcher respond? How many ways?
4 out of 5.
Well, you got a dispatcher and you got how many cars?
4.
4 cars. And the 4 cars can either be sent out or not sent out. Do you agree?
Yes.
So how many options do you have for each car?
2.
So you got car 1, car 2, car 3, and car 4. Each car only has 2 options. Go or no go. Does everybody see that? This was confusing, wasn't it?
Yes.
Yep.
Yes.
But if you think about what they're saying, all right, they can send out either 1 car or all the cars. But what are they talking about? Sending them out. Either send them or don't send them. That's only 2 options for each car. So that means you have 2 raised to the 4th power. You could write it like that. Okay. Or you're just going to say 2 times 2 times 2 times 2. How many ways can they send out these 4 cars? How many ways?
16.
Do we see it? If you think logically about it, if you was the dispatcher, you listening to the person on the other end, you got the choice. Either you're going to send a car out there or you're not going to send a car. That's all you got. 2 choices. Is that clear to everybody?
Yes.
Yes, ma'am.
Yeah. Number 20. And I know we're over. Thanks for hanging in. All right. So number 20.
Thank
It
you.
says,
for hanging in.
thanks. It says, if you have a spinner, okay? Here we have a spinner that has some colors on it. Okay. So it says, if the pointer is spun once, okay, find the probability it will land on a red or yellow region. So we have red, white, yellow, pink, green. Okay, we got all these colors. Tell me the key word in the problem.
Or.
And what do we say we know about or?
Add and subtract the overlap.
That's right. Add and subtract the overlap if we have any. How many total colors do we have or areas do we have on the wheel?
8.
8. So the probability of us getting a red, how many reds are there?
2.
2. So we got
2.
2 over 8. plus how many yellows?
1.
Okay, 1/8. Do we have any spots on there that are both yellow and red at the same time?
No.
No.
Nope. So we don't have to subtract anything. So now we're going to add these together and we get what?
3.
3 over
8.
Can't simplify it. That's all we got.
Can you
Can
do
we also
21 or is
really
it too long?
quickly? Oh, I'm sorry, I didn't mean to cut anybody off.
Yes, I'll do 21. Go ahead. What was the question for 20?
I was gonna say 21 as well. Thank you.
Oh, okay. But is everybody all right with 20?
Yes, ma'am.
Yes.
Okay. So now
21 sounds like a favorite.
this. So now if the pointer is spun twice, okay, what is the probability it will land on a pink region twice? What are we going to do now? What's the key words there?
Twice?
What does that mean? What does that tell us?
Multiply by 2.
2.
No, but you're halfway there. Twice means that we're going to do something in succession.
Add.
Not add, but probability of pink.
Multiply.
Right. The first time and pink the second time. Do you see that? So once they add on 2 or more things, now we got to, it's an and problem. Now we're going to be multiplying. Okay. So now what's the probability of us getting a pink the first time?
1/8.
Okay. 1/8. And then the probability of us getting a pink the second time.
1/8.
1/8. Is everybody still
Excuse
good?
me, Dr. Hamilton.
Uh-huh.
Dr. Mays, I'm sorry. Can I be excused? I'm actually at the hospital and they just called us in saying that my sister is like gone. So can I be excused for the rest of the day?
Oh, yes, please.
We'll send you the recording also, so when you're able to, you can watch it.
Yes, ma'am. Thank you.
Uh-huh. All right. So when we're multiplying, now what's our answer?
260.
Is it
What is it?
116?
160. 160.
1/64.
1/64.
There you go.
Oh, we're
Sorry.
adding.
Right. Make sure you're not adding. Right. We're multiplying when we're doing an and problem. So do we see the difference between the two now?
Yes, ma'am.
Yes.
Or we're going to add and subtract the overlap. But with that circle, there's really never any overlap. Okay. And then when they ask you to do 2 or more things at the same time, then we know that that's an and problem, and we're going to multiply those 2 or 3 probabilities, however many they want you to do, multiply those together. Any questions about it?
Awesome.
Yeah. Okay. So this thing right here.
So does twice need to multiply?
Oh, wait, say it one more time.
Twice means to multiply it. Do you and?
It means it's going to be an and problem. So and you multiply. Yes.
Hey, can you do 22 real quick?
All right. So 22, it says, here we have the Titanic mortality data. So they give you this table that is people who are survived, who has died, and they're broken down by men, women, boys, girls. And they give you your totals. Totals are important. So if they don't give you totals, you got to find them. All right. So then it says, find the probability that the randomly selected Titanic passenger is not a boy. What do you think you want to do? What's the key words in here? What are they asking us to do here?
Not.
Not.
Not a boy. So subtract.
What are we subtracting?
64 from the total.
Okay, go ahead and subtract out those boys from the total. So we have 2,223 people that is totally that they're counting. We're going to subtract out the total number of boys. And when we do that, that means that it'll be those people who are not boys. Am I right?
Right.
Yes.
Okay.
Yeah.
So 2,223 leaves us what?
2,159.
2,159.
Okay. 2,159 is going to be divided by what number?
223.
The total. This is the probability of the passenger not being a boy. Does everybody see that?
Yes.
Yes.
You did just subtract 64 from the 2,223, right? My little
That's
thing went
correct.
off. Okay.
All right, now if you can simplify this, simplify it. But ultimately, that's all we're doing. You're going to get rid of all the boys from the total. Whatever's left got to be those people who are not boys. Make sense?
Yes.
That's going to go for any of these ones that says, what's the probability of the person did not get an A for a grade or a B for a grade? So if it's one of those grade problems that you saw in the homework,
Yes.
okay? So if it's one of those not ones, remember that's complementary. So you can either use the formula that they gave you in the lesson notes, or just simply subtract those people who got that letter that you're looking for from the total, and whoever's left, put that over your total amount of the total people who are in the study.
Dr. Hamilton, how did you say do that again? 2,159 divided by 2,223.
Yes.
And then hit the second.
We'll push enter.
Right.
Right. And then push your second and then your F to D button to see if it can be rewritten as a reduced fraction.
And then hit enter again?
Yes.
Nope, it just gives it as a decimal.
Okay, so it can't be, don't worry about it. That's it.
Maybe show me how to do that, but on a TI-84 plus calculator.
All right, go ahead and put that in the calculator and push your math button. And the first selection would be FRAC for fraction. It's already highlighted for you. Just push enter twice.
So 159 divided by the 2223 number, and then press math. You said?
Push enter.
Oh, press enter.
You should get a decimal.
Okay. And
then push the math button.
All right. Once I press math, what do I do next?
Well, you should see it's already highlighted for FRAC for fraction. It's already highlighted.
Oh, so press enter.
Just push enter twice.
Okay, thank you.
And then I just have one more question. I'm sorry. So when it says on number 23, it says, given that the passenger survived, would we go for our denominator? Would we go to total people survived and put that as the denominator and then put the women over it? So, okay, yes, I'm thinking the right way.
Yes.
Okay, I just wanted to make sure.
Yes, those, but put the women in that category for the survived.
Yes,
so
ma'am.
Right, so you should have 318 over 706.
Yes, ma'am. Okay,
yeah.
Perfect. Thank you so much. I appreciate you staying later too. I know we all do.
Absolutely. All right, look, good luck, everybody. going to, let me see if I can put this sheet. I'm going to give, oh, yes, Wendell, did you raise your hand? Yes.
Yeah, so how would you do 23 again?
She was asking about the word given. The given is our keyword there. So that's our conditional probability. So probability of the Titanic passenger being a woman, given that they survived, right?
Okay.
So if they survive, this is a fraction. This is like your numerator over your denominator. So do your denominator first. So how many people survived? So go over to the total and you have 706.
Right.
Right? But out of those people who survived, how many are women?
318.
And then see if you could simplify it or not. Okay? Make sense?
Yes.
Yes, ma'am.
Mm-hmm. Always do with the given, always do your denominator first, okay? Because what it does is it shrinks your sample size so that you're looking at something specific about what's going on, but not your total population, but a specific amount of your population. Okay?
Oh.
Seriously though, are you teaching 1107 next semester?
No, not next semester. No, I'm not.
Yeah, I tried to look for it.
Oh, bummer.
All right, thank you guys so much. The sheet that I wanted to give you, I'm going to stop sharing right now so I can pull it up. It's just a highlighted sheet that kind of identifies the key words for you.
Awesome.
I'm going to pull it up and then I'll put it in the chat for you.
Thank you.
Absolutely. Okay, here is. And I just went through the whole entire unit and outlined each different topic, formula, etc., and then talked about it. You can make flashcards from it. And hopefully it'll help. Okay. Tell me if you'll be able to open it. Okay.
I'm not seeing it in the chat yet.
Yeah, I thought let me see. No. Let me see if it'll let me do it this way. It let me drag it before. Of course, it won't let me do it now. Oh, is there a size limit?
I don't think so.
Try this.
Can you just bring it up where they could do a screenshot of it, or is it too big?
It's a few pages because it's
Oh.
it's the whole entire unit.
Okay.
So here's what I will do.
Because you know they all got their phones ready.
I know. Yeah. Is it opening? Okay. All right. So here is starting at the beginning of the unit. and walking you through your fundamental accounting principles all the way down to understanding factorials.
We're not seeing it open yet.
Oh, it's not?
No, it's still just showing the list.
It wants to, how about that?
Yeah.
Yep.
Okay. All right. So it starts with factorials, and then I'll go there, and then it looks at going through factorials and permutations. It walks us right through our notes. Okay. Give you the formulas, the breakdown of the parts, the keywords that you need to look for when you are identifying whether it's going to be a permutation or a combination. So a range, lineup, order, or if it's first place, second place, third place, or president, vice president, secretary, that type of thing. Just some examples of things you should look for with combination. Again, some keywords, committee, team, group, choosing one or various types of items or people from specific categories, things of that nature. And what I want to do is I want to, can we send this?
Yeah, as soon as you send me the list with their emails on it, I can send it out as an email.
Yeah, I'll send this.
That would be awesome.
Yeah. How to manipulate the complementary events, how to deal with independent and dependent, with and without replacement, looking at making sure we're paying attention to those words, what you do with and I give some examples where needed so you can see how to use it with using our deck of cards, looking at our conditional probability and what you need to do first, second, and third when you're performing that particular problem. The steps to make sure you know which order to go in when you're setting up the problem. Okay, so coming from the words to some of the words to the setups. So hopefully this will kind of clear up some things, even when it comes down to our odds circles, odds and probability circles. I color coded it so you'll know exactly which direction you should be going for odds in favor, odds against. When you're doing probability of the event happening, the probability of the event not happening, and making sure you're looking at the wording which tells you the direction that they want you to go. So this document, you can make some flashcards. You can just use it as a study guide. You can use it as muscle memory if that's what you like. That works. And then use the picture of the cards that I'm sure your instructor gave you to look over and just be familiar with the cards. Again, you're going to have that on your test. So you should not have to worry about memorizing the whole deck of cards, but you should be familiar with what the structure is and the different names and parts so that you can at least be aware. Okay.
Okay.
Thank you.
Absolutely. We'll try and get this to you. I'm mad that it won't let me do like I did before. And
Was the other one, is it PDF or Word?
It's a PDF. And so I have the Word document.
Try sticking it in just in case.
The Word document?
Yeah, let's see.
Let's Let's see if it'll let me. Yeah.
Oh, Sierra, that's very nice. Congratulations.
How about I'll send it to you and you can see if you can get it to shoot over,
Okay.
because it's being
Who knows, right?
yeah. My computer's been really ugly to me. So give us just a second. I'm going to send it over. Okay, Vera, it's coming. I'm going to send you both forms as well, so just in case one comes.
Okay.
Yeah,
because I haven't gotten either one yet.
coming over right now. Okay.
Let me put it on my desktop and see if I can drag it from there. Here it goes. It's in the chat.
It's in. Good.
I put it in the PDF and the Word. So whichever opens the best for you guys, you'll have both.
Yes.
Are you also able to like email it how we got like this notification as well?
We can't send it via text because text won't always do attachments like we did. As soon as we get the list that's cleaned up with all the names and emails on it back from Zoom, then I could send it that way. So as long as everybody's name's very clear, you know, it's easier to follow it that way, we can send it quicker.
Right.
Would you like for me to type my email in the chat so it can be easier just in case?
It doesn't hurt, because I know there was somebody in here earlier that had the same name as somebody else, and I sent him one of the handouts and it went to somebody else. So he had to give me his correct email just to make sure.
So that is helpful. Yes.
And then let's see, I wanted to make sure the other one, the test review videos, there's also copies of the test review videos on the Learning Commons website. Actually for test 2, because we didn't get a chance to